In 1905, Einstein published his theory of special relativity, which explored the link between space and time.
In Einstein's view, there isn't really a separate thing. There's space and then there's time. But there's just one thing, space-time, that we all live in.
He thought of this new space-time as a fabric weaving together space and time. In 1950, Einstein developed his theory of general relativity, which modified special relativity to include gravity and its effects on this fabric of space-time.
Welcome to the bouncy trampoline of gravity. We've taken our fabric of space-time, stretched it taut, and placed a heavy weight on it. See how it warps the fabric of space-time. When we roll the ball across the fabric, it magically seems to be drawn or attracted to the massive weight at the center.
General theory of relativity was a new theory of gravity, one that told us that gravity worked because space and time were curved in the presence of matter and could respond dynamically. Space itself could expand and contract in the presence of matter. A crazy but true idea.
Mass is a term used to describe the energy and matter that objects contain. The larger the mass of an object, the greater its distortion of the space-time fabric, the stronger the effects of gravity.
Gravity is not really a force. It's a fabric. It's a shape of space and time. And we just move along the curves of these shapes. And the act of doing so takes what would otherwise be a straight line to you and bends it into what you now describe as orbits, as trajectories, as pathways through the cosmos.
Einstein said not even light can escape the effects of gravity. As crazy as this sounds, proof conveniently arrived in 1919 in the form of an astronomically large experiment based on a solar eclipse.
General relativity said that if you look at a star on a path of light that goes right past the sun, you would see it shift just a little bit because of the gravity of the sun. So Arthur Eddington actually went out to test that theory during the solar eclipse of 1919 and actually photographed stars when the sun was blocked by the moon and you could see the stars behind it.
The ability to see objects that were actually behind the sun proved that objects could warp space-time. Einstein became a superstar overnight. He received the Nobel Prize in Physics in 1921. But general relativity opened a Pandora's box for Einstein.